Good morning to a new chapter. Today we're going to be looking into chapter 7, coordinate geometry. Alright, coordinate geometry. So today I'm going to be covering these 5 things. So firstly, we're going to have a little recap about certain lower form topics, specifically distance, midpoint formula, and also going to be looking at different forms of the answers, basically like gradient form, intercept form. Then we're going to be looking at a divisor of a line segment. This is basically trying to find the point in a line, on a line, based on a specific ratio. And then we're going to be looking into parallel and perpendicular lines. This will also cover perpendicular bisectors. Then we're going to be looking into area of polygons. This is really good when we're trying to find area on the graph if it's not really easy to see. And lastly, we're going to be looking at equations of loci. This is a very important topic, I would say. It's quite difficult to get at first, but should be an easy one. Alright, lower form recap. So what do we need to know? Alright, so number one, let's look into the midpoint formula. This one's like one of the first few one of the first few things we learn in basically straight line in lower form. But basically, midpoint is what its term means, which is the center point of a specific line. So the formula that can be given is basically the value of the 2 points. So let's say if I give you point 1, put 1, 2 and point 6, 8, right? And I want to find the midpoint of this line. I would just have to sub this in to give you 1 plus 6 over 2, and also 2 plus 8 over 2, which would give you 7 over 2, and 10 over 2, which is 5. So this is the midpoint of between these 2 points. Alright, so next one we're going to be looking at is distance. Alright, so for distance, this one's also another easy one to remember. Just have to remember that you got to use the square root x1 minus x2 plus y1 minus y2. Alright, so let's just use the same values from the top here. I wanted to find the distance between these 2 points. I would just have to sub it back in to get, don't forget the square up top there. So you just get 6 minus 1 squared plus 8 minus 2 squared, and I would get 5 squared plus 6 squared, so that's 25 plus 36, and then the square of that, so I would get an infinite number of 7.81. Let's round it off there to 7.81 units. So just keep in mind x1 and x2 are interchangeable. That means you could let x1 equal to 1 or 6 as long as x2 is vice versa. Alright, so it has to be like 1, 6 or 6, 1, something like that. And y1, y2, same concept between 2 and 8. Alright. Now, another thing that we have to recap on is the forms of the line equations. So basically, I'm sure everyone is aware of gradient form, which is y equals mx plus c. But then we have 2 other new forms. I forgot if it's been covered in low form, but the intercept form is basically x over a plus y over b equals to 1. So a and b being your x-intercept and b being your y-intercept, alright? And then general form is ax plus by plus c equals 0, where c is your y-intercept. So this is same with gradient form, like gradient form where c is your y-intercept, but m is your gradient instead. So let's make an example. Y equals mx plus c. I'll give y equals 2x plus 4. So let's make an example. So sometimes questions will ask you to give your answer in like maybe intercept form or general form. But we're so used to writing our answers in gradient form that it is almost like a trap. So let's say I want to change gradient form to intercept. you basically just have to take y equals mx plus c. So y equals 2x plus 4. You bring both y and x to the same side, so y minus 2x equals to 4. And then you have to make this 4 into a 1. So you divide the whole equation by 4. So you'll get y over 4 minus x over 2 equals 1. Therefore, from here we already know that 4 is our y-intercept. We can already check it here from C in the start. And also, we know that 2 is the x-intercept. So that's like a new value. So now let's try a gradient to general form. So general form is much easier. It's just like normal algebra. You just bring everything to the left side. So y equals to 2x plus 4. What you do is just, okay, let's just write it back down. Y equals to 2x plus 4. Bring everything to the left side. Y minus 2x minus 4 equals 0. And you already got your answer. That's the general form right there. Alright? So that's just it about the forms. Just remember them. Alright, so let's go into divisor of a line segment. So this is something like finding the midpoint, but with ratios, basically. So the easiest way to explain how this formula works is by creating a line. So when you're doing your working, I always recommend to draw this line over here, right? It really makes you imagine how it looks like. But basically, we have to have 2 points, which is A and B, which is usually on the end of the line. Those points will usually be given unless you have to find the unknown. And then M and N over here are basically the ratio between, in this case, A and C and C and B. So M is basically AC, whereas N is CB. So the way the formula works is that, so you can see actually I wrote arrows from M to B and N to A. Basically, it's to signify that the value of x and y in B will be multiplying with M, and the value of x and y for A will be multiplying with N. That's why when you can see the formula to find the coordinates of C is where nx1, that means x coordinate of A times N plus x coordinate of B times M. So it's going to be like different sides. So it's like crisscross. And you have to always keep in mind that the denominator will always be M plus N. Actually, this can be deduced to where nx1 plus mx2 over M plus N will equal to x. In this case, the x value of C in this case. But I want to show you guys an example of how to answer this question to make it easier. So usually, questions will give you something, say like this. They give you 2 points, find the other point, which is C. They will always say it's on a straight line, and they will also mention something like this, 3AC equals 2BC. If they don't give you an immediate ratio, they will usually give you something like this, where AC equals to something BC. So this is not a ratio. This is still an expression, an equation like that. So what you need to do is to change it into a fraction and then into a ratio. So the way you do it is, so it's 3AC equals 2BC, right? So you bring AC and BC to one side and all the normal numbers to another side. So in this case, I'm going to do AC over BC equals to 2 over 3. So from here, you can actually make it to where it is the same thing as AC to BC equals to 2 to 3. Basically, you could make this also as BC over AC, so you become 3 to 2. Both ways are completely normal. But after you've found the ratio, this is when you have to draw that straight line. Okay, let's imagine this one point is A, the other end of the point is B, and the point in the middle is C. But then I know that A to C is 2, whereas B to C is 3. And then always write the coordinates of A and B on the line so that it's easier when you want to find the values. Because I always like to draw these arrows so that I know that they are supposed to multiply by the other, as in 2 times B instead of 2 times the x, y coordinates of A. So once I've drawn my diagram, this is when I can start finding the coordinate of C. So I know that C will equal to 2 times 7 plus 3 times -3 over 2 plus 3, and also 2 times 17 plus 3 times 2 over 2 plus 3. So from here we're going to get 14 minus 9, 5 over 5, that's 1. And also 34 plus 6, 40 over 5, 1, 8. So that is our point C. Then we found it. Alright, now we're going to be looking into parallel and perpendicular lines. So basically, we know that it's a parallel line when both lines are going in the same direction and they are not going to meet ever. So basically, we can deduce that since they're not going to meet, they have the same gradient. And that means, based on the two equations I wrote there with m1 and m2, we can deduce that m1 will equal to m2, as in they both have the same gradient. But keep in mind, they do have different y-intercept. That's why I wrote here, C1 does not equal to C2, alright? A very important one. Now then, for perpendicular lines, we instead have a different one. Instead of both gradients being the same, it's actually like both gradients are completely opposite. Basically, the other is going 90 degrees away from it. That's why we can say that m1 times m2 equals -1. So another easy way would be to like state it as m1 equals to -1 over m2. This is another way, but m1 times m2 equals -1 for me is like very easy. But now I'm going to show you guys how to do a perpendicular bisector question. This one is quite important. It's asked very widely during AddMaths questions. But basically, they will tell you to find the equation of the perpendicular bisector of a straight line which joins certain points, in this case E and F, right? So you have to keep in mind that a perpendicular bisector means that it bisects the line equally in half. That means it's bisecting the midpoint. So when we have E and F here, you can't just choose some random point. You have to find the midpoint of EF. So let's use that midpoint formula. So -1 plus -3, right? So that's -3 over 2. And then there's -11 plus 5 over 2. So our midpoint is -4, -2. And -6, -3. There you go. So that's the midpoint. So we know that the equation is going to be y equals mx plus c, right? This is going to be the formula of basically the perpendicular bisector equation. So right now we have the point to sub in, right? Because we're going to sub it in over here, right? But we don't know our gradient, we don't know our y-intercept. So I know that I can find my y-intercept by subbing it in, but how am I going to find a gradient? We can just use the m1 times m2 equals to -1. Since E and F is a line, I can actually find the gradient of EF. So let's find gradient EF. Let's just use our gradient formula, yeah? So I'm pretty sure everyone remembers that. So it's just 5 minus -11, so it's plus 11, over -3 plus 1. So that's going to be 16 over -2. So 16 over -2 is the same thing as -8. So what would be gradient of our perpendicular bisector then? That would mean that, so let's say that this is m1, right? So I know that -8, alright, -8 and m2 will equal to -1. So that means I know that m2 equals to 1 over 8. So from there, we already know that our equation is going to be, our equation right over here is going to be y equals 1 over 8x plus c. So I want to sub in my value, sub -2, -3, because we know that for sure the perpendicular bisector will pass through the midpoint of our line EF. So when I sub in the value, I'm going to get -3 equals to -1 over 4 plus c, so that I can find the y-intercept. So -3 plus 1 over 4 is 12, -11 over 4. Therefore, our perpendicular bisector equation is y equals 1 over 8x minus 11 over 4. Right, just like that. Alright, now let's look into area of polygons. Alright, so basically some questions will just ask you to find the area of like a shape that they've drawn on the Cartesian plane. It could be literally anything. A trapezium, a triangle, a square, a rectangle. All of it doesn't matter as long as it's a regular polygon. Actually it doesn't have to be, it can be an irregular polygon as long as it doesn't have curved sides. So for any polygon, you can just use this formula, all right? Even a pentagon, even an octagon, you just have to know what the value of the points are, the coordinate of the points are. But basically, you have to identify every point here. So in this case, it's A, B, and C, right? You have to know every point. And then you have to change it down into this form. Basically, you have to arrange it. I recommend arranging it like maybe like in a counterclockwise direction, like you go A, B, C or C, B, A, and then you arrange it. But basically, you have to do like A, B, C, A. You have to repeat whatever you put at the first one. So if you started with B, so it's like B, C, A, B again. That's how it works. You have to make sure if there's 3 points, you're gonna have 4 X and Y's in the formula over here. But basically, you see my little crosses over here. This basically signifies that it's going to be like y1 times x2 or x1 times y2. But basically, you always start from x to y, as in you start from our x stop over here to the y2, and then you go to the y1 and the x2 over here, okay? That's why you can see down here, it's x1, y2, alright? And then there's x2, y3 over here, and there's x3, y1. Only after that we see x2, y1 over here, then we see x3, y2 over here, you know, and x1, y3 over here. Basically, you just have to understand how this formula works. You don't have to remember the like specific placements down here. Even I have not memorized it. I just memorize whatever's on the top here so that I can change it into the bottom form. But let's look at a question on how to answer this. But basically, this is a good example. They give us 4 points, so we already know that 4 points is for sure a square, right? So if we have 4 points, that means we're gonna have to write 5 x and y values, right? So let's write this out. So area square, you know, because I don't know what this is. Area square A, B, C, D will equal to 1 over 2 modulus, and then let's start with from A, right? 2, 3, then B, 9, 8, then C, -2, 11, and then D, -5, 4, and then back to 2, 3. Alright? So then, I always like to write my crosses so I know which one's going to multiply by what. If not, it's going to look quite messy. But over here, we're going to get our 1 over 2, and it's going to be 16 plus 99 minus 8 minus 15, and then it's going to be minus bracket 27 minus 16 minus 55 plus 8. Keep in mind there's a lot of minuses here because we are working with negative values like -2 and -5, alright? But after we're done calculating, we're going to be left with 1 over 2 mod 128, and then we're going to be left with 64 units squared. Alright, so that's a quick rundown on how this formula works. The reason why we have the modulus is because sometimes you might be calculating an area of a polygon that is on like the let's say the third quadrant or it's usually the second, third, or fourth quadrant, which have negative values. So this the modulus is supposed to be like balancing it out. Alright, now we're going to be looking into probably the hardest part of this chapter, which the easiest way to explain is to actually do it. Okay, so basically there are going to be like 2 situations. The first one is when they say point P moves such that its distance from point A is always 5 units. So this is saying that you have to find the locus of P that is moving a constant distance from A. So basically, the way this looks, like we learned in lower form, was like this. So let's say this is A, right? 3, -4. And then we have P, which is a literal circle, which it's basically having A as the center. Alright? And then we already know that the distance from point A to the basically like the circumference over here will always be 5 units. So how do you find this locus of point P, right? So it's actually in the question by itself. Distance. We have to use distance formula basically. So what I like to do is I like to let locus P, well, more like the distance itself. So I like to label it as PA equals to 5. This is like the exact way my teacher taught it to me. PA equals to 5. So PA being the distance between P and A. But we don't know what P is, right? So what you usually have to do is you have to let P become XY, alright? So then you can actually make this into a distance formula. Oops, squared over there. So this is actually the same thing as x minus 3 squared plus y plus 4 squared equals 5. Oops, I wrote the wrong values, didn't I? x3, y minus 4. Oh wait, I did. I wrote the right ones, no worries. Alright, so x minus 3 and y plus 4, because negative cancel each other out. Alright, so after that, you just have to expand the whole equation. You got to bring the square root to the right side. So you have to actually expand this. So it'll become x squared minus 6x plus 9 plus y squared plus 8y plus 16. Don't worry about the speed I'm doing this. Make sure you guys do it at a comfortable speed. If you can't expand as quickly as I do, take it at your own pace. And that's going to be equal to 25 because we bring the square root to the other side, right? Now, you got to make it look like a quadratic equation. Basically, bring everything to the left side, even all of the y. Which you're going to be left with is x squared plus y squared minus 6x plus 8y plus 25 minus 25. So it's going to be since it's going to be plus 25, and then bring over minus 25, so it's going to be 0 again. So there is no power 0 unknown, and that's basically the locus of P. Alright, so keep in mind your arrangement has to be something like this, where x is first and then y squared. Basically anything with a higher unknown goes first. So it's like x power 2, then y power 2, then x power 1, then y power 1, then the other value which does not have a unknown. But in this case, since ours equals to 0, it's like doesn't matter, as in the 25 minus 25 equals 0. But alright, now let's look at the second question, which is another tricky one. Basically this is the one where they tell you point P is basically is away from point A and B in a certain ratio. So the way this looks, it's more of a straight line, I would say. But the easiest way to explain this is like, let's say this is B, let's say this is A, ratio 2 to 1, right? So it's something like this. So this is locus P. It's like is away from A and B from a certain distance. Keep in mind, this the way I'm doing this question works whether there is no ratio, as in let's say point P was equidistant from A and B. You would just have to write PA equals PB. But in this case, since we know that it is in the ratio of 2 to 1, that means we know that PA to PB equals to 2 to 1, alright? Because it says P is the distance from A and then B. That means PA will be equal to 2, PB will equal to 1. So this is like backwards of our first topic, which was divisor of a line segment. You know, we want to change it into ratio, but this time we want to backtrack to changing it to fraction. So if I change it back to PA over PB will equal to 2 over 1, and then we cross multiply to get PA equals to 2PB. Alright, so from here we just do like the same distance formula. Keep in mind P is XY, right? So PA will become it will become x minus 4 squared plus y minus 2 squared equal to another square root, which is, oh, don't don't forget about the 2, alright? We're going to be multiplying the 2 at the front there. But basically, it's going to be x plus 5 squared plus y minus 1 squared. So we can actually cancel out our square roots over here, but keep in mind of the 2 over here, this 2 over here is going to be squared. So, alright, let's expand all this in one shot, alright? We've got to be quick when we answer AddMaths questions. It's going to become x squared minus 8x plus 16 plus y squared minus 4y plus 4 equal to 2 to the power of 2, right? So it's going to be 4. I recommend not expanding that right side fully immediately. So it'll become 4x squared plus 10x plus 25 plus y squared minus 2y plus 1. Alright, we've got it down. Now we've got to expand it. But I want to be faster. That's the things you gotta sacrifice when you're doing AddMaths. You gotta keep it cool, you know. 4x squared plus 40x plus 4y squared minus 8y. Okay, I skipped that 25 because I know that 25 can be added with 1. So 26 times 4, 52, 104. Alright, 104. And then I'm going to bring all of this to the left side, alright? So it's going to be equal to 0 for sure. You should probably write the left side again. I was just getting lazy over there. 4y plus 4. But you should be left with this answer, which is 3x squared plus 3y squared plus 48x minus 4y plus 84. Alright, equal to 0. Always keep that in mind. And don't forget, I arrange my things by power and then finally with no power. So this is locus, probably the hardest part of this topic. But it's easy. It's easy when you get the hang of it. Just have to keep practicing, especially. But just keep in mind, let's say our ratio was 1 to 1, or they will usually use the term equidistant, as in point P was equidistant from A and B. Then you would just have to immediately write PA equals to PB instead of wasting your time with all the ratios over there, okay? Alright, so before I end the video, let's look at some quick tips. So number 1 is probably working with unknowns. So actually knowing how to do this, all those formulas just now was basically like the basics. Being able to use those formulas were like the bare basics of this chapter. When you start doing K-bar questions, they're going to ask you to find unknowns. They're going to tell you to find like certain shapes, find that locus. Is very difficult, especially perpendicular bisectors. They might even ask you to find what was the closest distance. It's a very hassly topic. Working with unknowns is a very big thing, especially. Another one is actually, like I mentioned just now, find the nearest distance. Alright, so this could actually be used in our later chapter, which is chapter 9, solution of triangles. But basically they will give you this triangle. I don't know why it's not becoming my straight triangle as usual. Alright, but basically they will give you like say this point and this point, A, B and C. Actually they'll give you all the points, but then they will ask you to find the nearest distance between point A over here and the line BC. Alright, so the nearest distance wouldn't be our AB over here or AC over here, right? The nearest possible way to get from A to BC is actually this perpendicular line right here. So when you answer this question, it's more of using your concept of perpendicular bisector. So usually you will find like you will find line of BC, you will find line BC, and then you will sub the values of A, so that you will find this perpendicular bisectors equation. But other than that, I think my last tip would probably just be relax. Honestly, this chapter is hard. I can't lie. I was struggled with this chapter when I was in Form 4 too. But alhamdulillah, you get better over time. So just keep practicing. It's a very formula heavy topic. So when you get used to using them, it gets much easier. So don't worry about it. Hope you guys enjoyed the video today. Look forward to the next ones. Ciao!